I'm going to discuss state design pattern. So, as the programming language, here I use C Sharp, and as usual, I will explain an example code for state design pattern. Once you have understood the logic in the code, then you should be able to apply the concept to your own problem. And then now let's see state design pattern in C Sharp. The state design pattern is a dynamic version of the strategy design pattern. Now, strategy design pattern. So, in this playlist, I have uploaded another video explaining strategy design pattern in C Sharp. Please go through this video before you try to understand this one, because state design pattern is a dynamic version of the strategy design pattern. Now let's try to understand the example code. First we have an interface. The name of the interface is IS. You already know that as a convention in C Sharp, we start the names of interfaces using capital S. Okay. Here I have given the name as IS for the interface. Interface contains two method signatures. M1, this will be the method name, and then C, capital C, simple C. Another method signature, capital C, simple C. Then here C means, now we can see a class called C. Therefore, the parameter, the type of the parameter is capital C. Type of the parameter is capital C. Now you can see here, I have not specified access modifier for these methods. The reason is, in C Sharp by default, the access modifier of all the members is public. By default it is public. Therefore, now these two methods have their access modifier as public. Okay, so now let's move to class C. Class C. Then inside this class, we have a field public. This is the access modifier. Public const int L. We assign value 5 to L. Here the const, the meaning of this one is, this field is a constant, okay, and its value is 5. That means if we create objects from this class, each object has a field called L and its value is a constant. We cannot change it, and here the value is 5. Since it is a constant, we can access value of L using capital C dot L. Okay, capital C dot L. Just like class fields, because if you consider class fields, okay, fields can be divided into two categories, no, class fields and instance fields. I mean class fields means static ones. Okay, static fields we can access using class name dot. Okay, in the same way, since this is a constant field, okay, even though it is an instance field, we can access it using capital C dot L, class name dot L. Okay, now I am going to discuss the next field. Public is, okay, this is not a field, okay, sorry. S get set. This is not a field, this is a property. Okay, I hope you are familiar with properties in C#. Now here this is a property, name of the property is capital S and its type, return type, or let's say return type, it is is, and access modifier is public. We have both get part and set part. When we execute this line of code, then an underline field will be created. Underline field will be created. For simplicity, let's take simple s as the underline field of this property. Okay. Now and one more thing. Now underline field is S, its type is is. Okay. Then let's move to the next line of code. Public int p, to the p we assign value of L. This is an instance field. Okay. Now let's move to the method available inside our class C. The method name is R, and it takes an integer value t as the parameter. If value of t, if the value of t equals 3, then it returns s dot m1 this s dot m1 this. Okay. Here capital S means it is our property. Therefore, we can think as we access simple S field, because underline field is simple S dot m1. Now the other thing is later we will create two classes like this, class S1 okay, class S1, okay. It realizes from IS interface. Another class S2, it realizes from IS interface. Therefore, an object of type S1, memory location of an object of type S1 can be stored in S variable, because type of S variable is IS. Therefore, an object of type S1, if you consider an object of type S1, the memory location of an object of type S1 can be stored in S, and also memory location of an object of type S2 can be stored in S, because S1 and S2 both of them realizes IS interface. Okay, now if you consider S1 class, we have two methods, M1 and M2, because you know that S1 class realizes from IS interface. Therefore, IS interface, since the IS interface contains two signatures, M1 and M2, two signatures are there. No? In each of these class, we must implement both of these method signatures. Therefore, now you can see M1 and M1 and M2 here, and also here you can see M1 and M2. Okay, so now the meaning of this one is S dot M1, here we pass this. This means our class is C. This keyword refers the same object, okay, same object. Okay, then this refers the same object, because the memory location of C object we pass to M1 method. Okay, so here now we return S dot M1. S dot M1 means M1 method, we invoke M1 method available in okay, so if S refers to S1, if our S variable refers S1, then we access M1 method available in S1. For an example, if S variable refers S2, then we access M1 method available in S2. Okay, so in that way you have to understand. Else here, else we access SM to this. Similarly, you can understand underline field is simple S. If S is storing an object of type S1, then M2 method inside S1 object will be executed. If S variable is storing an object of type S2, then M2 method inside S2 object will be executed, and as the parameter we pass the memory location of object C. Here C is the same class, we pass as the parameter. Now let's try to understand the two classes S1 and S2. If you consider the interface, we have M1 and M2 method signatures. Now the class S1 realizes IS interface, and also class S2 realizes IS interface. Therefore, it's the responsibility of both of the classes to implement both M1 and M2 method signatures. Now let's see this one here. We implement M1, we implement the method M1. There what we do is we access C dot P. That means the P field, we access it and add 4 to it and then return. Okay, that's what we do here. In P field is there, no? Okay. Then the next, in the next method M2, we check the condition C dot P, okay, C dot P. Now what is C here? C means we pass memory location of an object of type C. Okay, therefore this simple C is storing, memory location of an object of type C. Okay, therefore now here we access its P value, C dot P, if it is less than capital C dot L. Since L is a constant, we can use class name dot, okay, capital C dot L. Then if the condition is true, what we do, we create an object from S2 class, okay, then C dot S means now the underlying field is simple S. To the S field we assign the memory location of the object we created, sorry, this should be S2 from the S2 class, okay, S2 class. Now after that we put a colon, and then after that we reduce 7 from P and return. We reduce 7 from P and return that value. Okay, that is about S1 class. Then let's discuss S2 class. Here we have a method called M1, method called M1, it takes an object of type C. Okay, now simple C is storing the memory location of an object of type C. Now value of P, the value of P field in this object will be incremented by to the value of field P we add 9 and return. Okay, that is how method M1 works. Method M2 in our S2 class here as the parameter we take a reference of type C. Then here also here we actually check the condition C dot P less than capital C dot L. If the value of P is less than L, in that situation we should create an object from S1 class. We should create an object from S1 class, okay, S1 class. Then its memory location should be assigned to S. This is the underlying field of property capital S, okay. So to S we assign the memory location of this object. After that we put a semicolon, and then we return, we reduce 8 from P value and return that value, okay. So that is our S2 class, the methods available in S2 class. So I have discussed both of the classes. I hope still everything is not clear, okay. But when I discuss the main method, you will understand everything. Now I am going to discuss the class program. In this class we are going to include the main method. Therefore, to this class we call the driver class, okay, because we have the main method inside this class. Now inside the main method, line by line will be executed. So this is the first line of code that will be executed. Then let's see. Then C. Therefore, an object of type C will be created. Let's see our class C, okay. Then inside this one, an object of type C. Inside this class we have a constant field. The value of it is 5. Then we have this one. The property underlying field is simple S, okay. The type of S is IS. Type of L is integer. Now this one, it is another field of type integer P, okay. Initially, since we assign L to P, initial value of P is also 5, and to S we have not assigned anything yet. Therefore, value of this one is null. Okay. Now to our simple C, we have assigned the memory location of the object we have created. In addition to that, here we have our R method R. Okay. Then we execute the next line of code. C.S, C dot capital S. This is the property, therefore we access the underline field to the to S, simple S, we create an object from S1 class. Now you know that this is our interface. We have two classes, S1 and S2. We realize S1 and S2 classes realize from IS interface. Okay, IS interface. Now we create an object from S1 class, let's say this one, and its memory location will be stored in S. Okay, so let's represent it like this. Memory location of the created object now is stored in simple S. Okay. Now let's look at the first line of code. We try to execute C dot R, we pass 2. If you look at T method available in C class, there you can see, it takes T. Now T value is 2. If this condition is false, T value is 2, no, condition is false, therefore this one will not be executed. Instead this one will be executed. That means it will return S.M2. We pass, this means actually here we pass the memory location of this object. In other words, okay, memory location of this object. In other words, the value of C we pass here. Okay, value of C we pass here. Then this is our property, therefore this works for simple S. S.M2. S.M2 means S dot, that means S is stored in the memory location of this particular object. Its M2 method inside this object will be executed. Now let's see S1 class. There M2 method. This one. So let's see now, M2 method is this one. So now we pass memory location of this one. Therefore the C variable inside this M2 method is also storing the memory location of this object. This is the C variable inside M2 method. Okay. Now this is also stored in the memory location of our object. Okay, so now it checks the condition c dot p less than capital C dot L. C dot P means 5 less than C dot L means 5. This condition is false. Okay, condition is false, therefore this block will not be executed. Then it comes to this line of code. It will return, it will first reduce 7 from P. Value of P is 5. From the 5 we reduce 7. The value is minus 2. Now the new value here is minus 2. And minus 2 will be returned by this. Okay, minus 2 will be returned by this. In R method, yes, if you look at the R method, now here we executed this one, then from this one minus 2 will be returned. Therefore this R method returns minus 2. Here we get minus 2. From here we got minus 2. Therefore from here we got minus 2. Then after minus 2 we have a space, therefore we get minus 2, sorry, here we get minus 2 and an space. Okay, from first line, this one. Now again see now again let's move to the next line of code. We pass C dot R, we execute the R method and pass 3. Okay, C dot R3. Then let's look at the R method inside our class C. Here now we get T as 3, then this condition is true. T, now T, value of T is 3, condition is true. Therefore what happens, this one will be executed, this line of code will be executed. It returns s dot m1 and it passes the memory location of this object, or else value of C as the parameter. Then s dot, here underline field is simple s, therefore s dot m1, that means m1 method of this particular object will be executed. So now let's go to S1 class. this one will be executed, and to the M1 we have passed the memory location of this object. Therefore, the C variable available here will also store the memory location of this particular object. Now it accesses C dot P. C dot P means this value is -2, and to this -2, 4 will be added and that value will be returned. It will add 4. That means here this value becomes 2, value is 2, no? 2 will be returned. Okay, 2 will be returned. Two will be returned from here. Okay, from here 2 will be returned. Okay, then if you consider this particular class, here 2 will be returned, and therefore this R method also return 2. This also returns 2. Therefore you can see two, then n space. You can see here 2 and space. Okay, now these two values as the output you can see. Okay, and then it's the time to move to the next line of code. Now here C dot R 0, we pass 0. C dot R 0, C, this is the object, R as the parameter, we pass 0. In C class, this is our R method. Then we pass 0, therefore this condition is false. Therefore it comes to here. Actually this line of code will be executed. Will be executed S dot M2 to this. This means we pass the memory location of this object. We pass it. S means actually simple S, underline field is simple S, this object. Then M2 method of S1 object will be executed. Now let's move to this one. M2 S1 M2, this one. Okay, then M2 now, since we pass memory location of this object, now inside M2 the variable C will store the memory location of this object. Then we check the condition C dot P less than capital C dot L. C dot P means 2. Less than C dot L means 5. 5, no? C dot L means 5. This condition is true. Therefore these two lines of code will be executed. Okay, these two lines of code will be executed. That means c dot s, c dot s, c dot capital S, that means this one, will be assigned new S2. That means from S2 class, an object from S2 class will be created, and its memory location will be added to S. Okay, this S variable can hold one value at a time because that is a variable. Therefore, this link is no longer here. Now S stores the memory location of object of type S2. Okay, so now you can see, if you consider this particular object, its memory location is not stored anywhere. Okay, therefore C# compiler will delete it from the memory, because now since its memory location is not stored anywhere, we cannot access this particular object. Okay, we cannot access this particular object. Therefore C# compiler deletes this kind of objects from its memory. Okay, from its memory. Now S variable stores the memory location of this particular object. Then after that it should write a colon. Okay, now you can see in the output a colon is here. Okay, a colon is here. Now C dot P. Now C dot P value it returns C dot P value. We C dot P value we reduce 2 from C dot sorry, 2 is the value, we reduce 7, then value is minus 5, and we return the value minus 5 here. Then this one, value of this one is minus 5. C dot P, now new value is minus 5, minus 5. We return from here minus 5. From M2 we return minus 5. Since this return minus 5, this method is also returning minus 5. Okay, so you can see here now the output minus 5. You can see it here minus 5, then a space. Okay, then let's move to the next line of code. Then c dot r we pass 4. This object we execute the method r, okay, we pass 4. This is the method r. Here we pass 4. Therefore, this condition is false. Now, as t we pass 4, condition is false. Therefore, this line of code will not be executed. This line of code will be executed. Then SM2, as the parameter we pass the memory location of this object, okay. Then M2, now you can see SM2 means M2 method available inside this particular object. Therefore, let's go to our S2 class. In S2 class, we have to go to S2 class. Then M2 method available inside that class. Okay. Then now you can see in M2 method the value C it refers this one, okay, refers this object. Now it checks the condition, C dot P, C dot P means minus 5, C dot P means minus 5, minus 5, C dot P, the condition is C dot P, capital C dot L, then minus 5, 5, okay. The condition is true, therefore these two lines of code will be executed. An object from S1 class will be created. S1 class will be created, and its memory location will be assigned to S, this one. Now, as in previous situation, this S variable can hold one value at a time. Therefore, this link is no longer there. And if you consider this object, its memory location is not saved in anywhere. Therefore, C# compiler deletes this object. Okay. Okay. Now, after that, we put a semicolon. Semicolon you can see here. Okay, semicolon you can see here. Put a semicolon. Then after that, it comes here to C dot P value. From the C dot P value minus 5, we reduce 8. We reduce 8. The value is minus 13. Minus 13. Therefore, this will return minus 13. Minus 13 will be returned from here. Okay, then if you look at this, minus 13 will be returned from here. Therefore, this will also return minus 13. Now you can see here minus 13 and then an space is appended. Space is appended. Okay. Now let's move to the next line of code. C dot R1. We pass 1 to the R method here. The condition is false. So this line will be executed s dot m2 and we pass the memory location of this particular object. Then m2 method available in class S1 because object is of type class S1. Let's go to class S1 and M2. This method will be executed and C variable now stores the memory location of this object because here we have passed the memory location of this object. Okay. Therefore, C stores the memory location of this object. Now it checks the condition C dot P less than capital C dot L. C dot P means minus 13. It is less than 5. It is less than 5. So the condition is true. Therefore, these two lines of code will be executed. From here, an object of type S2 will be created. An object of type S2 will be created and S its memory location will be assigned to S. S can hold one value at a time. Therefore, this link is no longer there. Now, since memory location of this object is not saved anywhere, the C# compiler will delete it from the memory. Then after that a colon will be written. So if you look at the output, you can see this colon, okay, colon. Then after that, from the value of p 7 will be reduced, then the value is minus 20. Then new value is minus 20. So this will return minus 20. So if you look at yes, here it returns minus 20, therefore this R also returns minus 20. Okay, therefore if you look at the output, you will see minus 20 and it will append an space, therefore minus 20 and then space, sorry, minus 20 and then space. Okay, so minus 20 and space. So here we have any space, it's difficult to highlight, don't worry. Anyway, minus 20 and the space. Okay, minus 20 and the space. So now let's move to the next line of code 3. C dot R3. C dot R3. Okay, then C dot R3 means R method available in class C this one. Now parameter is 3, therefore this condition is true. Value of t is 3, this condition is true. Therefore this line of code will be executed. S dot m1, then we pass the memory location of this object. Okay, now S m1 method available in S2 class. Okay, now let's go to the S2 class. let's go to the S2 class. M1 method. M1 method available in S2 class. Now here simple C, this will also store the memory location of this particular object, and then C dot P means minus 20 to minus 20, 9 will be added. The value is minus 11, value is minus 11. So the new value is minus 11, minus 11. Then then if you look at this, minus 11 will be returned from here, and then this will return minus 11. Okay, so minus 11 will be returned here, then from here also minus 11 will be returned. Okay, then if you look at the output, now you can see minus 11. Then here we append an space, minus 11 and space. Okay, minus 11 and space. Space, I will highlight the space like this. Minus 11 along with the space. Okay. Now let's move to the next line of code. Again we pass C dot R, again we pass value 3. Okay. Then C dot R method of class C will be executed. T value is now 3, therefore the condition is true. Therefore this line of code will be executed. S dot M1 M1 memory location of this object will be passed. Then S dot M1 means now S is storing an object of type S2. Then M1 method will be executed in S2 class. Now let's move to the S2 class. There M1 method in S2 class. Now here C is also referring this particular object. That means memory location of this object is stored in this C, this one. Okay, then what happens? C dot P C dot P. Okay, C dot P is minus 11. To that we add 9. Value is minus 2. Now this value is minus 2. Minus 2. Therefore, this one returns minus 2. Okay. This M1 method returns minus 2. After that, R method from here we get minus 2. Therefore, R method also returns minus 2. If you look at the output, you can see minus 2. Minus 2, and then we append any space. Therefore, okay. Then we need to move to the next line of code. Okay, next line of code. Then this one, C dot R2. C dot R2. Then we invoke the R method. Then let's move. R method, this one. There now this condition is false. Therefore, this line of code will be executed. M2, S dot M2, and memory location of this object will be passed. Okay. Now S dot M2 means M2 method available in S2 class. Now if you now in this M2 method, this C variable that stores the memory location of this object. Okay. Now we check the condition C dot P less than capital C dot L. C dot P means minus 2 less than 5. Condition is true. Okay. The condition is true. Therefore, an object from S1 class will be created. And its memory location will be assigned to this. Okay, now this variable can hold one value at a time. Therefore, this link is no longer here. And now this object, if you consider this object, its memory location is not saved in anywhere. Therefore, C# compiler will remove that object from memory. Okay, then after that it writes a semicolon. If you look at the output, you can see the semicolon. Okay, then after that it moves here. C dot P, P value is minus 2, then minus 8, okay, then value is minus 10. Now new value of P is minus 10, therefore this will return minus 10, and if you go to this one, minus 10 will be returned from here, and then R method will return minus 10. Okay, minus 10 will be returned. So here this line of code will write minus 10 and then append an space, sorry, minus 10 and an space, minus 10 then an space as well. Okay, now let's move to the next line of code, the last line of code. C dot R4, C dot R4. Now let's move here actually. Uh, 10 and then space only, okay, something like this. So ten and including the, sorry, uh, then and then I need to highlight only the ten and space, okay. Then R4, Then let's move to our R method in class C. Then if you check the condition is false. Therefore, this line of code will be executed as M2 and we pass the memory location of this object. SM2 we pass the memory location of this object. Okay, so now SM2 means now S is storing the memory location of this object, then M2 method available in S1 class. Now let's move to S1 class. Okay, this method. Now if you consider C in this method is storing the memory location of this particular object. Then we check the condition C dot P less than capital C dot L. C dot P means minus 10 less than 5. The condition is true. Okay, condition is true. Therefore, these two lines of code will be executed. That means an object of type S2 will be created and its memory location will be assigned to S variable. Now this variable can assign one value at a time, so this link is no longer there. Now the memory location of this object is not stored in anywhere. C# compiler, therefore C# compiler removes this object from its memory. Okay, now in addition to that, a semicolon will be written. If you look at the output, now you can see the semicolon. Semicolon will be written, semicolon and space, okay, along with the space. Not only the semicolon but the space. Okay, okay, then semicolon, then after that, not a semicolon, okay, sorry, colon, a colon, okay, colon, then after that C dot P value is minus 10, then minus 7 will be reduced, the value is minus 17. This value will be returned by this method. So if you go to here, now minus 17 will be returned, therefore R will return minus 17, okay. Now you can see minus 17. Now the whole output. Okay, now you can see the entire output minus 17 will be returned along with an space. Okay, and in that way I have finished discussing each line of code, and that is the okay. In that way we can discuss state design pattern. Okay, now I hope now you can very clearly understand the logic behind state design pattern. So you should be able to apply the concept to your own problems, not only in C#. If you know any other programming language, using any other programming language, you should be able to apply the concept. Okay, and this is the end of this video, and thank you for watching.